Good morning. So, in our last lecture, we saw different properties for creating this steel steel items. Let's open the design sample project. Last lecture, we saw how we are adjusting these properties of column and position. Also, we saw today we will be going to see the beam properties and the other all other properties will be going to see today. So I'll just double click on this beam icon. This horizontal member is shown as beam and vertical will be is shown as column. So I'll just click here where it says create beam, create steel beam between 2 points. You pick. So when we pick 2 points, beam will be created in between those points, right? And this is the property of beam properties. These are the beam properties. So in attributes, we see that this is similar to what we saw in column properties. The attribute part. The attribute part is quite similar to column properties, right? And only thing is that the prefix attributes contents are different, little different, but the presentation of this attribute is same. Like numbering is there, attributes are there. Okay, all this name, profile, material, finish, class, part, and assembly, prefix, and start number. So all those contents are same. Few changes are there, like name will be column, and here name will be beam. Okay, and properties are also different for both. Okay, this is column properties and this is beam properties. Okay. So same thing we can do here. Like if I want to choose member size, so I have to go here in the catalog selection. Just press on the select button, and you will be asked to choose the desired beam member size from or the column member size from the catalog. Okay. So we can just pick any of the required properties which is mentioned in the design drawing. So that way we can add the properties from the catalog. Okay. So it is quite similar to how we did in the column. Then material grade is also same thing. You have to choose from the listed grades, and all these grades are from environment. So whichever environment we are choosing, we will receive that specific grade properties in our model, right? So this is environment specific. Okay, these properties and all this material grade, these are all environment specific. Okay, so whenever you change the environment, you will not see these listings, okay, in the catalog. So these listings will change according to the environment type you choose, right? So like for example, here you are seeing now UB, UC, Okay, universal beam, universal column. See, if I choose Indian environment, then you might be seeing ISMB, ISMC, ISA. Okay, all those properties related to Indian standard. Or say if I have chosen US US environment, so I'll be listed out with I'll get the wide flange members like W16, W10, W12, WT. Okay, all those are US properties or US standard. So I'll be getting the US standard catalog when I'm choosing a US environment, right? So that way we can apply any required environment and we can get those catalogs or related member sizes in our catalog. Okay. Then we'll move on to position, and here we saw that levels will be given and position was there. Similar in the beam also there is position, but this position is different. Okay, here there is right left, here there is down and up. Okay, and here left right, and here front bottom. Okay, so but rotation will be same: front, top, back, below. Front, top, back, below. So rotation will remain same for both. The options for rotation will remain same. Only this tab is not there. In column, we have this tab for uh, adding levels, right? So last lecture we saw how if we add some certain levels, so how that column gets added in the model, right? So you have to pick point for the column, and it will be added according to this point, this dimensions or these lengths. These are actually the Z levels, we can say, from 0. Okay, so reference is from origin for these values. Okay. But on the other hand, on beam, you won't find this kind of options for Z coordinates, because in beam we'll be providing XY coordinate or XZ coordinate. Okay, so that's why here Z coordinate dimensions are not there inputs. So beam will be placed based on 2 points we are providing, right? Start and end point. So here you can see a yellow color is marked for the start point, and pink color is marked for the end point. So whenever we are modeling a beam in model, just start modeling. Just click on the beam, start point, end point, and I will just select the beam and I will just zoom in. You can see this looks like a yellow point and this looks like a pink point. So yellow point is the start and pink point is the end, right? So it will be like the first point which I choose, that is a yellow, and second point which I choose, that is pink. Okay, so now see, you can see the orientation of beam is now changed because I have picked the first point on the right hand side and pink point on the left hand side. And this orientation is different because this point I picked on the left hand side and second point on the right hand side. Right? So these points will depend on how you pick. Okay, so first point will give you the start point and second point will give you the end point, right? You just saw how beam properties are applied, okay, and how we are adding the beam in model. Then we have create polybeam steel beam that passes through points you pick. complete the command by clicking middle mouse button. You can also chamfer the corners. Okay, so this is also very good tool for adding a polybeam. With this icon on itself, you can see uh, this beam is not actually a straight beam. Okay, it's in a different. It goes in a different axis. Okay, so start to end, it is not in a straight axis or in one axis. After second point, it moves in a different direction, right? So direction of the axis changes here. That's why we call it as a polybeam, right? So we'll see how it will be added. So I'll just click here. First point, second point, third point, middle point. So this beam looks like a polyline. Okay. If you have done AutoCAD, in AutoCAD, when the lines uh, are continuous, when you select a single line, it shows as a continuous line. Even when it goes in different directions, then it is called as a polyline. Okay. So what is polyline actually? It is made of different segments. Similarly, polybeam is also made out of different segments of a beam. Okay, these are the segments of a beam. So that's why we call it as a polybeam, right? And we have, if you can read here, we have chamfer. You can also chamfer the corners. Okay, chamfer the corner means uh, whenever there is a bend, you can click that bend, double click, and you will get the chamfer properties. Okay, at those bends, wherever it gets bends, at that location you can double click on the node points, and you will get the chamfer properties, right? So here we have a lot of options for modifying this uh, bend. Okay, this bend we can modify. Say, so here I have given a chamfer for this end. Similarly, if I want a chamfer at this end, I will just pick that corner and I will say this with these properties only. I will say modify. So now you see how it is used. Actually, it is a quite good option whenever you want to add some kind of chamfer or some kind of continuous member. Then we can use this polygon effectively. Let's remove this points. Say radius. Now we will see another property of this polygon. So this is also quite handy property. You can see I can add a radius for those bends, smooth radius. So that's how we are using a polybeam. There is one more use of polybeam, which we will see now. For that, we need to add a construction circle. First point, second point. Now, okay. So now we'll add a beam here, polybeam. Third, first, second, third. 3 points I have given. I will click middle button, and now I will show you the different property. Again, we have to go in for the chamfer, but here we will not enter radius now. I need a curved surface. Right? So instead of adding radius, I will go for this option. And let's see what happens. I'll just modify. Now it has converted into a circular shape, a semicircle. So this option is very good for adding this kind of members also, polygon. Right? It is also very handy tool for adding curved shapes this way, in this manner. So similar to polybeam, we have another option, curved beam, because curved beam is related to this kind of shape. So I will show you how it has to be added. So here now in curved beam, if you can see, we have radius. So special option is there in the beam for curved beam and number of segments. Right? So we have to keep an eye on that. When I want to add, I will just click first point, second point. I selected beam option. Instead of beam, you have to go for create polybeam, curved beam. First point, second point, third point. So that's it. When you provide 3 points, the curved beam will be added in the model. So that is the way we add curved beam in the model. Now for what is the difference between curved beam and a poly beam? Is that we can add n number of points for poly beam, but for curved beam we need to add only 3 points. Okay, so that is a difference between curved beam and poly beam, and between those 3 points, it will get the radius of that curved beam of that beam. Okay. So when I double click on this properties and go in the position area, you will see the radius is applied here with the 3 points which we have provided. But when I zoom this curved beam, you can see this it is like a segmented. It is not a smooth shape. It's looking like segmented, right? It's not matching the circle. What we will do, we have to increase the number of segments. Here there is a segment option given here. What we'll do, we'll just increase the number of segment to 60 and we'll see what happens. Now it is segments have increased and it looks like a proper circular beam or curved beam. Okay, this is more proper curved shape. Okay. So with increasing number of segments, this curve shape will look like a proper curved, proper circular shape. Okay, but here we don't need that adjustment because it is taken care automatically when you provide a chamfer. Okay. Curved option given in the chamfer. Right. So that's the difference between both of these beams. Okay, and we saw curved and the poly beam right now. Then we have a contour plate option here. Create contour plate. Right. I will just click here. What does this say? Create contour plate, polygon shaped steel plate. Using 3 or more points you pick to complete the middle mouse button. Click middle mouse button. The pick points define the shape and select the profile thickness. So here only we are providing a thickness. So nothing else. Only thickness will be provided and 4 points. So that will give us a plate. Right? So what I will do? Pick points 1, 2, 3, and click middle mouse button. So with this, you can see plate is created here, and there is a slight thickness available for that plate. So when I say if I need to modify this thickness, I have to modify it from here. Okay, you have to add the value here after PLT, there is numeric value. Right? So that value we have to change. So whatever value you need, you can enter there. Okay, so that's how we are adding the plate, contour plate. So this is contour plate properties, and here member size selection is not there. Only thickness we can add, and material grade also we can add. So properties are somewhat similar, but different is on the profile side. For member size, there is no option for a catalog here. This is quite so this is like a fixed member, right? Only this kind of members will be able to model contemplate. So but the rest other values are same, but in position only we have this option, middle, front, behind, and the offset value. Okay, only one option is given in the position, so there is no position tab additionally here. So that's how we are modeling a contour plate. Okay. Also, here we have properties like a this thing, polygon. Okay, polybeam. So we'll just try out one option that we tried in the polybeam. So yes, we have a tempered properties here for contour plate also, like polybeam. So we can modify this plate like a polybeam also. So I'll just say 1000 modify. So yes, it is working like a polybeam chamfer. Okay, right. So yeah, it works like a polybeam chamfer. So with this also we can get circular shape or any kind of shape we can add. Right. So we saw how we are adding the contour plate and the basic profiles. We saw how we are going to add. Now we'll see how we are going to add a bolt and weld. So these are the bolts. This is a weld. So for that, we need numbers. So I will just move this beam above by say 1000, and what I will do, I will add some plate here. Okay, I will add a connection manually. So I will just say create basic view, create default views of part. So I will get 4 basic views. Right now, what I will do, I will add a plate here. Okay. Go to beam property. I can create a plate from here also, or you can create plate with this contour plate also. Both the options you can use. So this thing we already saw. Like if I want to create a plate, just snap to these properties, beam properties, and I can draw a plate this way, right? So I have got one plate. Right? So I have moved it on the flange area, right? How? Just select the plate, right click, move spatial, linear. Now I will pick first point on this line and next point on this column flange perpendicular. So I got this distance and I will simply move it, right? So that's how we are adding this plate. Now I will add a cut here, fit part end, right? So I'm using this cut option, select the beam and add 2 points. The first point on the end plate, outside part of the end plate, and second point here. So with this, what happens? The beam gets cut. Beam point is showing here. Okay, beam point is there here, but it is getting a cut applied. Okay, due to cut, the length of the beam is restricted till the end plate. Okay, end plate, right? So that way we have added a cut in the model, right? Now we are going to add the bolt, create bolt. I need this view, so I will add primary part. Primary part will turn red. Secondary part is primary part, and secondary part is your plate, right? And I will say middle click. Okay, I have clicked on the middle button, and now I will add first point on the plate edge and second point here below. So with that, I got one bolt here. You can see. Yes, I got a bolt. Then I need to modify the properties of that bolt to fit in that plate. These are the properties. Bolt properties. You can choose the bolt standard from here. Different available standard as per the environment. Right? So this also goes with the environment. So whatever environment we are choosing, you will get those standards, right? And bolt diameter. You can choose the bolt diameter from here. So these are the two important things you have to select while applying the bolt, manual bolt, right? Generally, we don't need to apply this kind of bolts because this connection is directly, we can apply this connection from the components, right? So this option is there, but this we can also add the connection manually in the model. So this is the manual method which we are seeing right now, right? So here I will say 90. So this is the start point. I added the first point here, second point is here for this bolt. So start point is the first point, and there I have added 90. So that is the offset now. From 90, we have given offset here, right? Now still it is not showing a proper bolt because what is happening? We have not given a pitch, proper pitch. It is connecting to the web portion. That's why it is not showing proper. It is not showing properly, right? Some length is getting extended here because it has to fit the web area, right? We need this board actually on the flanges, not on the web. So we need to provide a y the this spacing in y, that is say 100, say modify, and now this bolt is showing correctly. You can see, yes, it is showing correctly now. Bolt, right? That is how we are adding a manual bolt, and from the spacing which I have shown, we'll be able to add multiple bolts also. This is like in X direction, if I want number of bolts, more number of bolts, so I will add here 75. We say modify. So now you can see another row is added. If I need some more rows, I will just simply add space 75 and say modify. Right. So it automatically gets clubbed. Okay, 2 into 75. So now I understand the rule. You have to just enter according to that rule. That is 3 into 75, 4 into 75, right? So it goes that way. Okay. You can go up to 4 volts in this B, right? So okay. So we have added maximum number of bolts we have accommodated in this connection, right? But here you can see it is quite near to the very near to the edge of the plate, so we can adjust the spacing here. Like if I want to say 80 mm, so now it looks clear and clean, catch free. Okay, the intention of this connection will be it should be clash free. There should not be any clash. Okay, so now now it looks okay in all the perspective. Okay, front view, side view, everything looks okay now, right? So that's how we are adding a manual bolt. Now we will add a manual weld. Okay, so this is a weld property. If I double click here, you can see there are type of weld listed here. Size of weld is given here. Right? I will simply apply here. Now I will not modify anything. I will simply apply from the basic properties. So primary part is the main part. Secondary part is a plate. So with this, I got the weld here. This is a weld symbol. Okay. Cyan color. When I double click, I will arrive at the properties here. And now I see there is all round weld applied to this weld. Right? So we can change this to normal weld. And whenever we are changing it to normal weld, you can see that weld is now displayed here. So I can add a weld here. You can say near side, far side. So both the sides, if you zoom here, you can see the weld is applied on the both side. Okay. So on both side, we can see that triangles are there now. So that means that weld is applied on the both side, right? So that's how we add this welding, right? So today we saw how manually we are going to add the bolts and all those things. We can check the spacings, can verify the pitch and everything of this bolt. How? But we have option here, measure bolt, right? I'll just click on this bolt. Okay, click on this option, select the bolt and select any part which you want to measure. So say I will say plate. So you can see it is giving me the dimension from plate. Okay, here it is not clear in the end view. You can see in this view bolt and plate. Now here it is clear. You can see all the dimensions are available, okay, to you. So also we can manually add these dimensions, these kind of dimensions. We can add it manually. Say for example, there is a vertical measurement. So first point, second point. So it is done manually means every point you have to give manually, right? So this way we can check manually also, right? So each bolt we can check, okay? Each dimension we can add manually. And also we can add through one option, that is bolt spacing measure. Okay, so it gives you complete measurement, right? So I will just add now this option to beam. So pick bolt and pick beam. So similar to this thing plate, we also get measurement for beam from beam. Okay, so this is from beam. So here actually the plate is matching with the beam. That's why we are getting the same dimensions, exactly the same dimensions, right? Now we'll go for column. We'll check the column dimensions. Select bolt and select the column. So you can get the column dimensions are also visible to you now, right? So you can check it manually. First point, second point, right? You can verify it manually also. If those dimensions are not visible properly, you can go for the manual input also. Let's say bolt and say column. Okay, so here also it will give you proper measurement. So what happens in a in the view where you are able to see the top view of the bolt, there only you are getting proper dimensions of that